So the reason I wanted to do this specific problem is because this is actually anytime you're dealing with temperature like this, temperature and cooling, you're actually going to be using a specific formula, which is called Newton's law of cooling. Which is UT equals capital T plus U sub 0 minus T times E raised to T, where T is the constant temp of surroundings. So in this case, T is equal to, what is this, 33 degrees. U sub 0 is the initial temp of the object. So what is that? 7 degrees Celsius. And K is just a negative constant. T, obviously, little t is time. All right. First things first, let me go back so I can see this. Okay. Oh, can you not see my? So now I'm just plugging in the values into my equation. So big T was 33 plus U sub 0, which is 7, minus big T, which is 33. E raised to the power of K times time. So now I need to, there's a variable here that I don't know what K is yet. So what you're going to have to do first, before you can figure out, okay, what does it read after 5 minutes, before you figure those out, you need to solve for K. Now they gave us an extra set of data points here of 17 degrees after 3 minutes. So in order to solve for K, all you have to do is plug these values into your equation and then solve K. So that's what I'm going to do. 17 degrees at, what was it, 3 minutes. Now I am just going to flip these around just because we're utilizing constant from a variable. So now I just have to solve for K. First things first, I'm going to simplify over here. So 7 minus 33 gives me how much? Yes, negative 26. And then also in the same exact round, I'm going to subtract 33 over. So 17 minus 33 gives me how much? Yeah. Now, again, I'm working towards getting my variable by itself. So what should I do next, do you think? What should be my next? Trying to get the variable. Yes, get the negative 26 off. Get it off. You don't want it on there. You want it off of the E. E is not a variable. It is a constant. Okay, we're not solving for E. We're solving for K. K is the exponent on E, so we need to get that negative 26. Now I'm just going to leave this as a fraction. I'm going to leave it as 16 over 26 is equal. You could get a decimal, but don't get anything out of this. Why? Okay. So 16 over 26, E raised to the power of 3K. And here is where we are trying to think about last year a little bit. And I know that we ended last year really roughly, right? So I don't even know if we started learning about Euler's number or like how to solve. But does anyone know how I would get rid of the E? Mm, okay, think of it this way. Yes, Sam. Yes. Right now, K is an exponent. So you can think to yourself, okay, how do you get something out of an exponent? What is the opposite operation of an exponential? The opposite of an exponential is log. Oh, Kim taught me that algebra. Okay, bear with me. The opposite operation of exponential, which this right here is an exponential term. The opposite operation of exponential is logarithm. All right. So normally, oh no, normally to get something out of an exponent, you do the opposite operation, which is log. Log of the same base. What is the base in this exponential term? E. Yes. So you take log base E of both sides. Now, math, because we understand that math is most useful in the real world, right? So something like E that is going to appear a lot in the real world and the natural world is going to have a very, very special log associated with it, right? Yes, we would take log base C of both sides, but does anyone know another way to write log base C? What's another representation of log base C? Someone already said it. Someone already said it. I believe it was Ellen. 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 Ln represents the natural log, right? E is that natural number that occurs a lot in nature. It has a very, very special log associated called the natural. But of course, because they want this to represent a log and logs start with L, they just switched the letters around. So instead of it being an NL, they wanted it to look more like a log, so they made it LN. That's all. It is LN. So here, opposite operation of an exponential with a base of E. Oh gosh, what am I even writing? Erase. Oh no, it's not erase. Okay. Opposite operation of an exponential with base E is ln. So you take the natural log of both sides, and the natural log and the base of E will cancel. Leave on this right-hand side with just 3 times k. On the left-hand side, I am going to find the natural log of 16 over 26. Negative 0.4855. K is still not all by itself. You need to still by 3. Did I lose anybody? To get something out of an exponent, if a variable is in an exponent, it's termed an exponential. To get rid of an exponential, you have to use log. You could have put in, if you don't like remembering, oh, ln is the special log for e. You could have literally typed in log base e. Where is it? Of 16 over 26 and gotten the exact result. Okay? It's just a very fancy log. No big deal. No big deal. All right, so now that we know K, so this is the first part of this, unfortunately. And now that we know K, we can find the two things it wanted me to find. What will the thermometer read after 5 minutes? So 5 minutes is the time. All I now need to do is type in 5 to my, now what I did, because I like my calculator, I like using my calculator, is I put this in my equals instead. So we have 33 plus 7 minus A. E raised to negative 0.618. And then our variable. So the reason I did this is because now I can just look for time 5 and get 21.422. And also in the exact same breath, I can look for time t. I'm sorry, time t, oh my god, 10, and get 27.844. Min. Just make my life easier. I believe there was a part B, but let's see if we graph the relation in the temperature time. No, because I trust that you guys can figure out how to graph. So I'm not going to go over that. Oh, I guess I do want to tell you just really quickly. MathXL will say, okay, which one of these represents the graph? And then it will say, it'll give like coordinate points like this, 0 to 10, I don't know, 2, 5, 0, 25. What this means is it wants your window, so it'll say the window set. It wants your window to go from 0 to 10 by increments of 2. So this is like scale. And then it wants your y values to go from 0 to 20 by increments of 5, the scale. This will just make it look exactly like the answer choices it's going to be, okay? Are there any questions on this problem?